quick little review, something that you guys do in science. If I want to know how many minutes are in a week, you guys remember what that process is called? Like, if I want to know how many minutes are in 1 week, I start with 1 week, and then how do I break it down? Like,
1 day.
Yeah, it's conversion. So then, where would the week go though? Bottom. So 1 week is the same as 7 days. And then what would the next one be?
1 day.
Where, on top or bottom?
Bottom. 24 hours.
Then what?
1 hour at the bottom. 6 days.
Okay. So the whole thing is, why do you know that like this day has to go on the bottom? Exactly. If you have the same thing on top and bottom, they cancel. And then in the end, if you want to know minutes, that's what's left over. This is called a dimensional analysis. So then when you did this, anything on top, what would all the top numbers do? Multiply. And if there was anything on the bottom, what would they do? Divide. So multiply on top, divide on the bottom. We're going to do something similar to this. Key part is, if you want a unit to cancel, it needs to go on the bottom. Whatever you want to end with goes on top. What we're going to start today is kind of the new stuff of trig, the difference between geometry trig and algebra 2 trig. So, random questions for you. If you wanted to measure how long this room was, what would be an appropriate measurement? Feet or meters, right? Yards, meters, whatever. So they would measure the same thing. Agree? It's just different units. What if you wanted to go from here to Fargo and know that distance? Miles or kilometers. What are like the miles, yards, inches, like what is that unit of measurement called? It's like US standard. What are meters, kilometers, centimeters? The metric system. Now, in reality, which one is easier to work with, the US standard or metric? Metric. What does the majority of the world use? Metric. There's only 3 countries that don't. We just happen to be one of them. Why? Because we're stubborn. That's really it.
We need to change it.
I agree.
We really do, because everything in like scientific methods is
Exactly.
metric systems. So you have to learn both.
That is the key part. In science, you use the metric system. The metric system is easier to work with, easier to convert between, and it's generally accepted. Like that is the science standard is metric. We're going to talk about kind of the same idea, but with angles. So we're going to talk about how do you measure an angle. Currently, what do we use to measure an angle? What would the units be? Degrees. So the first way to measure an angle is in degrees. Degrees in a circle. How many degrees are there in a circle? So 360 degrees make a circle. Why? Where does 360 come from? It comes from the Babylonians. So don't write this down, but Babylonians, Babylonians, so ancient people, they were base 60. So in their number system, they liked 60. Like they counted up to 60 and repeated. So this is their base number system. Do you notice how every single one of those numbers is unique? So they had unique numbers up till 60. They thought that it took us 360 days to go around the sun. Were they close? Yeah, so in their mind, once around the sun was a complete circle. So they said, okay, a circle has 360 degrees, which is pretty good for them, right? They were base 60, so then does 60 go into 360 nicely? Yeah, they really like the number 60. They kind of group things into 60, which for them was very convenient. Look at your knuckles. So take these 4 fingers. How many knuckles are on that hand, between those? 12. Do you agree there's 12 knuckles on these 4 fingers? And then 5 fingers. So when they counted, they used the knuckles on one hand and the fingers on the other hand. What's 12 times 5? 60. So when they like counted, they used knuckles and fingers. I don't know how, but I read it. I didn't get too into it. But that's how they counted. how do we count? Like, what's our base number? They were base 60. Our numbers are base. When you were in elementary school and you used those number blocks, they were called base 10 number blocks. Because don't we count to, like, we have 10 digits and then they repeat. Count, repeat. So we're base 10. Why would we be base 10? Why does base 10 make sense for us? 10 fingers. When cavemen were counting, did they have 10 fingers to look at? Yeah. So we're base 10, they were base 60. So we say that there's 360 degrees, kind of to pay homage to people who worked really hard to get really close to that number of closer to 365. So if you were on any other planet, would 360 degrees make sense for a circle? Would they come up with 360 if they were on any other planet? No, because obviously the sun's orbit, everything would be different. So when it says 360 degrees, that's based on the sun. That's not based on anything mathematical. That was them saying, like, well, we're going around the sun, let's call it that. What we're going to learn is another way to measure an angle is something called a radian. So a radian is mathematically pure. So instead of saying it's 360 because of the sun, we're going to say, well, how would we measure this angle based on an actual circle? Not on the sun, not on the planets, not on us, but on the actual shape. So a radian is another way to measure an angle. Instead of a degree, the radian. If you think about a circle, what word is kind of in radian? Radius. So it's based on the radius. That makes more sense. We're basing something about a circle on a radius. Does a circle have a radius? Yes. So the radius, remember, goes halfway out. And what a radian is it's based on the circle's radius. All circles are similar because the radius and the outside, like, they always have to grow evenly. So it says create a central angle. So a central angle just means it comes from the middle. And a radius has to fit on the arc that it creates. So this length is the same as the arc's length. So a radian is the angle that is needed right there so that this arc is the same length as the radius. So it's defining an angle based on its radius rather than the sun. So here would be, this angle would be 1 radian because 1 radius fits on the outside. If we do it again and we make another angle so that this arc is the same as its radius, this would be 2 radians because 2 radiuses fit on the outside. If we were to do it again so that we can fit another radius, how big is that angle? It's 3 radians because 3 of them fit. So we're kind of building the circumference, aren't we? Because we're talking about the outside of a circle. So then what's the formula for the circumference of a circle? 2 pi r. We like using unit circles, so an easy one to make a connection to is if this radius is a 1, then all the way around the circle is going to be 2 pi. So 2 pi radiuses fit on the outside of a circle. Like, that's exactly what this says. 2 pi radiuses fit, make your outside circle. So 2 pi radians is the measure of a circle. What is 2 pi as a decimal? Times 2? 6 point something. That means 6 and a little bit more radiuses fit on the outside. So this is mathematically pure because it's based on the radius, whereas this is based on the sun. Going back to degrees, 360 is all the way around. So then what's halfway around in degrees? 180. 2 pi radians is all the way around. So then what's halfway around? Pi. So that's exact. pi is a number, so about pi radiuses fit on the outside. We leave it in terms of pi because then it's exact. The key fact is that pi radians equals 180 degrees. We could say that 2 pi equals 360, but we can divide that 2 away to make it simpler to work with. So the key part is that there is a conversion. There has to be a conversion because they both measure angles. The key part is that pi radians is 180 degrees. So this is mathematically pure. If you take pre-calc, calc, anything higher than algebra 2, they're going to use a lot of stuff with radians because it's simpler in the fact of like there's no decimals here. We keep things as fractions and it's more exact. What do you think is bigger? 1 radian or 1 degree? 1 radian, because if you think about it, you'd have to fit 360 of those little guys around here, but a radian, you can only fit 2 pi of them. So it's just a different way of measuring that angle based on the radius rather than the sun. So if someone lived on any other planet, this would make sense to them. Would 360 make sense to them? No. The thing is, this is algebra 2. You haven't seen this before. So we kind of cheat the system. And rather than hammering in like radians, 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 we're going to learn how to convert between the two. Because you guys know how to work with degrees. You're used to working with degrees. So we're going to practice just being able to convert between the two. So if you want to know what 225 degrees is in radians, you can convert it. We're going to use kind of that dimensional analysis. So the key part is that 180 and pi are the same thing. If you want to end in radians, the pi tells you your radians. 180 degrees would then go on the bottom. Because if you put that 180 on the bottom, what are your degrees going to do? Cancel out. How do you multiply fractions? How do you multiply fractions? Straight across? Pi is a number, but we're going to leave it as exact and just leave the pi there. So really, we just have to reduce this fraction. 225 over 180, what does that reduce to? Remember, when you reduce fractions, you can reduce them multiple times. So if you're someone who likes to go piece by piece, this one ends in a 5, this one ends in a 0, so what can you divide them both by? 5. What's 225 divided by 5? What? 45. What's 180 divided by 5? Can you reduce 45 and 36 again?
Yeah.
What goes into both of those? 9. So then 5, 36 divided by 9 is 4. So 5 pi over 4 radians is the same as 225 degrees. They talk about the same angle. One of them is in degrees, one of them is in radians. What do you think the telltale sign is that this is radians and not degrees? Pi. So when you see a pi in an angle, it's probably going to be in radians. Questions on that one? All right, next one. Now it's 150. So always put a 1 underneath it. And if you want to end in radians, which one is radians, the pi or the 180? The pi. So whatever form you want to end with goes on top. The degrees are going to cancel. Fractions always multiply straight across, and that's just a 1. And this one is super easy to reduce, because if they're both zeros, what do those do? Yeah, it's like automatically reducing it by 10. 15 and 18, what goes in both of those? 3. So then 5 pi over 6. So 5 pi over 6 radians is the same as 150 degrees. So measuring the same thing, just 2 different units. It's like the first time you learned what a meter was. Same thing as a yardstick, just a different way of measuring it. Negative 135. they play the same way as degrees. So when you see a negative degree, what does a negative degree tell you? Yeah, it's just going down. So it means nothing within the conversion. So when you do negative 135, you can just do positive 135. And then in the end, make your answer negative. Because remember, a negative angle just tells you a direction. If you want to change it into radians, what goes on top? The pi is 180. Pi, what does this guy reduce down to? 3/4. So, measuring the same angle, just two different ways. Now we're going to go backwards. I'm going to change this one. Let's do so negative 2 pi over 5 radians. So that's an angle. It's negative. So is this angle measuring up or down? Down. But if I asked you, what does 2 pi over 5 radians look like, you wouldn't be able to tell me what it looks like. So we're going to convert it because we know how to convert between the two. The thing that's different, now I want to end in degrees. So what's going to go on top if you want to end in degrees? 180. I think these ones are easier, and in reality, going this way is going to be more important for us. When you multiply straight across. So you can just think of this as just one big fraction problem. You have a pi on top and a pi on bottom. So what are those going to do? Cancel out. So this is super nice. Your pi's cancel. So in your calculator, it's 2 times 180. And then what's that 5 going to do? Divide. So what's 2 times 180 divided by 5? 72. And then it was a negative, so it's negative 72 degrees. What quadrant does negative 72 degrees end up in? Fourth quadrant. So this angle right here, you could write it's either negative 72 degrees, or in radians, it's 2 pi over 5. So it's measuring the same angle, it's just one's in radians, one is in degrees. Last one, 7 pi over 6. It's always going to be pi and 180 you use for converting. Whatever form you want to end with goes on top. So if we want to end in degrees, which one goes on top? 180. I think these ones are easier because what do the pi's do? Yeah. So 7 times 180 divided by 6 is 210. Do you know where 210 degrees is? What quadrant? Third. So that angle is 210 degrees, or it's 7 pi over 6. What is 7 pi divided by 6? Like, what's this as a decimal? So that means that on a unit circle, you would fit 3.6 of the radiuses on the outside. So it's just using the angle being described by how many radiuses fit on the outside. But overall, they both measure angles. Since they both measure angles, there's a lot of numbers that you know how to do a lot of things with their angles. So this picture that I'm going to draw, it needs to be on at least half a page. Your first question on your quiz, on your test, on your homework, every day we are going to make this picture. And it's because there's key conversions that you just need to know by heart. So in our circle, degree-wise, we always said, well, it's 0 degrees, or what's all the way around? Halfway around the circle. So when I say like there's numbers we used a lot, I'm talking about like the sine and cosine of angles. Like what angles appeared? What do you know how to use with angles? So if this is 80, what's up here? Down here. So when we were finding sine and cosine exactly, we would use those angles, or 3 other ones would pop up. The first one that would pop up is 30 degrees because it's in a special right triangle. The next one that would pop up was 45 degrees. What do you think the last one that pops up is? 60. So these are our main angles that we use a lot. These are the nice angles to work with in trig. So we have to memorize what their conversions are in radians. The key part is that you know all the way around the circle is 2 pi radians. What do you think 0 degrees is? How many radians is 0? 0. You can't fit any radiuses outside 0 angle. So 2 pi in radians is all the way around. What's halfway around? Pi. This is the key fact that you should know to build the rest of this. So we're going to jump into fractions because pi is halfway across. 90, do you agree that 90 is halfway to 180? So 90 in radians is pi over 2. It's halfway. It's half of pi. 90 is half of 180, so it's half of pi. Another way to look at it, so do you agree that 90 times 2 is 180? What's 180 divided by 2? 90. So see, we're literally just taking it, dividing it by 2. So 270, how many 90s go into 270? 3. So it's 3 of our pi over 2. Because pi over 2 is 90, we take 3 of them to get to the bottom. All right, the last 3. 30 times what is 180? 6. So 180 divided by what is 30? 6. So do you agree 180 divided by 6 is 30? So this angle is pi over 6. Because you literally take your pi, you divide it by 6, and you get 30. 180 divided by 6 is 30. 45. How many 45s go into 180? 4. So what's 180 divided by 4? So 45 degrees is pi over 4. The last one, 180 divided by what is 60? 3. So what do you think 60 is? Pi over 3. So these conversions, these are all built off of once around a circle is 2 pi, and then from there, it's really just breaking it up into fractional pieces. Everything we do with degrees, we're going to do in radians. So back to how do you find exact sine and cosine, but instead of given degrees, you're given radians. So it's exactly what was on that half sheet of the quiz you took yesterday, except for now, instead of being told degrees, you're going to be told radians. And again, you know it's radians because there's a pi in there and there's not a degree symbol. We cheat the system. If we know how to do this with degrees, we're going to switch it into degrees. So I'm not going to force you guys to think of this only in radians because that's not fair your first time going through this. So we're just going to kind of make ourselves a little gap, and we're going to figure out what is 2 pi over 3 in degrees. So if I want to know what it is in degrees, what goes on top, the 180 or the pi? The 180. Cancel, cancel. So how many degrees is 2 pi over 3? 120. So what this question is actually asking us is what's the sine of 120 degrees? What's the cosine of 120 degrees? So those two questions are the exact same. One's in degrees, one is in radians. You know how to do this if it is in degrees. If you know your degrees, you can draw your angle. What quadrant is 120 in? To make your triangle. So on the outside is 120. So then what angle is inside the triangle? 60. Label your sides. In a 30-60, the 1 goes across from what angle? 30. So here's our 30. So there's our 1. What's the hypotenuse? 2, long leg, root 3. So the sine of 120 is going to have the same answer as the sine of 2 pi over 3 because they're the exact same angle. So in that quadrant, is sine positive or negative? Positive. It's in the S quadrant. And what is the sign of that angle? Yeah, square root of 3 over 2. So we cheat the system. If it asks you to do something in radians, figure out what it is in degrees, and then use the skills you already have. In that quadrant, is cosine going to be positive or negative?
Negative.
Negative. What does cosine stand for? Yeah. So we use the degrees to help us draw our triangle. And once you have that triangle, the exact same as what we were doing. Let's do another one. Now it's 5 pi over 6. So, first, if we want to find sine and cosine of 5 pi over 6, we should first know what the degrees is, because we have to be able to draw our triangle. Five pi over 6 is the same as how many degrees? 150. What quadrant is 150 in? Second quadrant. So if from here to here is 150, what's inside the triangle? 30. Where does the 1 go? Opposite, adjacent, hypotenuse. Once you have this triangle, nothing is different. In that quadrant, is your sine value positive or negative? Positive. So what is sine of 30? In that quadrant, is cosine positive or negative? Negative. What is cosine of that? So once you have that angle, you do the exact same thing. The trick is, when you do this, you're not going to have a calculator in front of you. So you either have to be really good at multiplying and dividing by hand, or start looking for patterns. On that beginning circle, pi over 6 is how many degrees? 30. So this is literally saying take 5 of those pi over 6's, right? 5 of the pi over 6's. What's 5 times 30? 150. So those are the sorts of patterns you should be looking for. Rather than using this right here, if you notice that the bottom number is one of the ones in that circle, you should try to do it mentally. So let's do the last one we're going to do here is 7 pi over 4. So to figure out this degree, look at the base angle. So when I say base angle, I mean like, what is it based off of? It's based off of pi over 4. So the base angle is the pi and then the number on the bottom. So pi over 4 is how many degrees? 45. That's in the circle. So this is saying how many of those 45 degrees do we want? 7. So what is 7 times 45? That's much easier multiplication. 7 times 5 is 7 times 5?
35.
35. 4 times 7 plus 3? 315.
Oh.
What quadrant is 315 in? If this is 315, what's in this triangle? 45. 45s are the nice ones, because if this ends in a 5, it has to be 45. Some trick that some of you will do it this way, and I'm fine with it. Pi over 4 is how much of a quadrant? How much of a quadrant is pi over 4? Half. So you could say it's 1, 2, 3, 4, 5, 6, 7. If you start seeing patterns like that, that's fine. All right, if you don't, ignore me. Cosine and sine. In that quadrant, what is sine, positive or negative? What do we label our triangle if it's a 45, 45? Sine is opposite over hypotenuse. What's that always going to rationalize to?
2/2.
Yep, so negative root 2 over 2. Cosine, is that positive or negative? Positive, and hopefully you're kind of starting to pick up on this. If this one is root 2 over 2, what's this one going to be? Same thing. They come from 1 over root 2, which will always turn into that. Grab a piece of paper that you are going to use for your homework. We're going to do some of the homework stuff together.
Probably. It's not. I mean, I don't know if it's super. Feels like that makes it big.
Yes, you and leave.
Feels like.
Are you going to go back or leave?
Yeah, so. Because he would have done the same.
Feel better?
As I did.
Leave if you need to. You decide what's best for you.
I had like an hour.
Okay, so you have 1, 2, and then we're just going to do a couple of the parts in 3 because this is the harder portion. Find the exact values of sine and cosine for the following radians. Be careful of your signs. So we're going to do 3e first. So 3e is 2 pi radians. That one you need to know. If it's one that's just straight up on your circle, you just need to know that 2 pi radians is how many degrees? 360. So 360 right there. If it's on one of the corners, can you make it into a triangle?
No.
No. So write down your order of pair. What's your order of pair right there? Positive 1, 0. So then the cosine of 2 pi and the sine of 2 pi. Remember, cosine alphabetically is x or y? X. So your cosine is 1, your sine is 0. So once you know what angle you're looking at, everything is the same. Let's do D. So D, negative pi over 4. That negative angle just means do you measure up or do you measure down? Down. Pi over 4, you know. What's pi over 4? 45. So this just means down 45. Does this look familiar? Is it the exact one we just did? Yes. So just like in degrees, a negative radian just means you measure it down. So then sine here, positive or negative? Negative what over what? Perfect, or 2 over 2. Cosine, positive or negative? Positive, root 2 over 2. So once you know that angle, you're fine. It's doing exactly what we have been doing. Let's do G. This will be the last one we do together. G. So G is 7 pi over 6. When you have a number on top and bottom, look to see what your base angle is. So pi over 6 is how many degrees? 30. So that's 30 degrees. And the 7 pi tells us how many of those 30 degrees we want. 7. So what's 7 times 30? So the angle we want to work with is 210. So when you have a number on, like, always look at the bottom number, see what your angle is, and then the top number tells you how many. What quadrant is 210 in? Third. So 180, how much further do we have to go to get to 210? 30. Is our 1 on the horizontal, the vertical, or the diagonal? Vertical. Across from the 30 is the 1. What's the hypotenuse? 2. What's the long side? So we just figure out our angle, same ruling. In that quadrant, is sign positive or negative? Negative. What is positive in that quadrant? Tangent. So we're negative sign. Sine of 30 is what over what? Sine 1 over 2. Opposite over hypotenuse. Cosine, positive or negative? Or 3 over 2. So these ones, the only difference is that you have to figure out what angle they're talking about. So we just did 3 of the 9 you had. First hour had less time than you, and a lot of them were able to finish these bottom ones. So your homework is that sheet, and then this maze sheet. This maze sheet is just practicing the converting. So the first part of this, it's all there. No? Okay. Number 1 asks you to draw that circle with all the degrees in there and the radians. That circle is the first question on your test. So you need to have that circle memorized. Number 2 asks you where radian comes from, and then the actual math is on the bottom part. Yeah.
What do we take in our test?
You have a quiz before the break, and then test will be when we come back.
Which
Right.
Oh yeah,
Hockey.
that's state.
State hockey.
Can we close that?
This homework is not going to be due till Monday, because tomorrow we have one more thing to go through, and then you'll get something from there. So tomorrow will be a nice clear up day.
Are we doing both sides? Okay. Yeah, I was like right.
And then this is also shared in classroom, but I will